The project was aimed to tackle one of the most important problems that disabled people face. That is the problem to control things through their hands, for example a fan. So we decided to do a voice recognition fan in which the fan was controlled on and off through the voice. First, the user is supposed to say on for it to be turned on, then off for it to turn off. And it's supposed to increase its speed via a voice recognition command. So we faced a problem through that and decided to change the course of the project. We changed the voice recognition to an ultrasonic sound. It detects a motion of 1 and 0. If there's an obstacle in front of it, it turns into a 0 and switches the fan off. If there's nothing in front of it, it's still a 1 and the fan keeps working. Then we have the temperature sensor, which takes a certain reading of the room temperature and compare it with a predefined value that we have and the temperature given by the temperature sensor is the same as the value given by the user. The fan stops. If it's below, then the fan keeps working. And then
and here we have a temperature sensor that measures the temperature of the room and inputs to Altera. It inputs the temperature to the Altera, and here it is displayed. The temperature room is 22. Then the user enters the desired temperature through these switches, like we see. And if the desired temperature is lower than the temperature of the room, the fan keeps on working. Otherwise, the fan stops, and we will see it working. So here the fan is working. The input is 10 degrees, so it's still working. But if we switch the temperature to 30 degrees, which is higher than the temperature of the room, it stops. Now we have manual.
And now with the motor drive. As dash bridge. It consists of two parts, an input port and an output port. The input port consists of 3 wires. The black wire is an enable connected to the Altera, and the red and the yellow are 2 inputs that take a combination of 2 bits from the Altera, a 0 and 0 to break and a 0 and 1 to make the fan start. And then the second part, the output, consists of 2. A motor connected to the fan, 2 wires, the yellow and the orange are connected to the breadboard, and the green and the blue are connected to the battery. The green one is the VMS connected to the positive part, and the blue one is the ground connected to the negative part. And now with Hamza.
And now is the ultrasonic sensor. Here's the ultrasonic sensor. It works as the following. It sends ultrasonic waves to detect a distance. If there is an object standing in front of that sensor, it automatically returns a 0 bit. Through this wire, it sends it to the Altera board. The other 2 wires are the 5 volt. It's connected to the breadboard, and the other one is the ground. And now let's turn on the fan. It's also showed in the 7 segments. The fan is now working. If there's an object standing in front of the sensor, like this, the fan will automatically stop. And now when the object starts moving away from the sensor, the fan automatically works. We also used the analog to digital converter. It's used to convert the temperature inserted from the temperature sensor as a voltage. And this voltage is translated into 8 bits. The 8 bits are inserted into the Altera board, and then with some calculations in the code, that 8 bits are converted into a temperature, which is shown here from the 7 segments.
Finally, the ultrasonic sensor is used to detect an obstacle in front of it. Whenever an obstacle is there, it sends a 0 value to the Altera, and the fan stops. Whenever it's a 1, the fan keeps working. And then we use a temperature sensor, which returns an analog value that goes through an analog digital converter to convert the temperature to an 8 bits that then goes to the Altera and is converted to digital value and displayed on these 7 segments. And we use the motor drive to connect the fan to the Altera and to the battery.